Welcome students, welcome to this session, thermal engineering session. In this session, we are going to see about in part 4, we are going to see about the biomass energy. So these are the sources of the biomass energy: the agricultural crops and residues, sewage waste, municipal solid waste, animal residues, industrial residues, forestry, crops and residues. So these are all the biomass sources. Biomass energy. Biomass energy is a plant or animal material used for energy production, that is for electricity or heat, or in various industrial processes as raw substance for a range of products. It can be purposely grown energy crops, example, miscanthus, switchgrass, wood or forest residues, waste from food crops, wheat straw, bagasse, horticulture, yard waste, food processing, the corn cobs, animal farming, manure rich in nitrogen and phosphorus, or human waste from sewage plants. Biogas energy. Biogas is the mixture of gases produced by the breakdown of organic matter in the absence of oxygen, that is anaerobically, primarily consisting of methane and carbon dioxide. Biogas can be produced from raw materials such as agricultural waste, manure, municipal waste, plant material, sewage, green waste, or food waste. Biogas is a renewable energy source. In India, it is also known as gobar gas. So biogas is produced by anaerobic digestion with methanogen or anaerobic organisms which digest material inside a closed system or fermentation of biodegradable materials. So this closed system is called an anaerobic digester or biodigester or a bioreactor. So this is how this biogas plant looks like. So this is the ground level. From the ground level, you have to dig a pit from underground that. So this is the inlet chamber, and in this inlet chamber only the dung and water mixture you have to pour it from the slurry of cattle dung and water. You have to pour it in this pit so that it will come to this underground pit. This is the underground digested tank, and this is the floating dome. And this from this floating dome is the biogas outlet. We are having a gas wall, and this is the outlet for biogas, and this is the remaining sludge which comes out. Let's see a video how this biogas plant is working.
Let's study about biogas plant. The plant has a dome-like structure built with bricks, an inlet valve and an outlet valve. It has a gas chamber where there is no oxygen. Pour the slurry of cow dung and water into the gas chamber. Gas is produced by the anaerobic microorganisms that do not require oxygen to decompose or break down complex compounds of the cow dung slurry. It takes a few days for the decomposition process to be complete and generate gases like methane, carbon dioxide, hydrogen, and hydrogen sulfide. The biogas is stored in the gas tank above the digester, from which they are drawn through pipes for use.
Download Spark Learning app.
So inside this biogas energy, these are the typical composition of biogas. So we having a methane 50 to 75%, carbon dioxide 25 to 50%, nitrogen 0 to 10%, hydrogen 0 to 1%, hydrogen sulfide 0.1 to 0.5%, oxygen 0 to 0.5%. Next comes the biodiesel production. So this is also one type of the biomass energy. So this biodiesel production, it's also we are using the biomass as a source. Okay, we are using the crude oil, with crude vegetable oil or any type of vegetable oil, and we are going to refine the vegetable oil, and using the alcohol we have to transfer esterification, so that we have to remove the glycerol, and that glycerol is used for food industry and cosmetic industry. If you remove the glycerol from the refined vegetable oil, then brings the biodiesel. So that biodiesel you can blend it with the normal diesel, or you can directly use it. Okay, so this is a major oil from the oil crops. It may be any plant, any flower, any seeds. From that we are extracting the oil, the crude oil. From that crude oil we are refining. Refining means we are removing the fat contents, and then comes the transesterification. During this transesterification, we are removing the glycerol, and after removing the glycerol, we get the pure biodiesel. This is the schematic diagram of biodiesel production process. Any seed oil, for example sunflower oil, safflower oil, seed oil. From the seed oil we are going for transesterification. Transesterification is the process of doing with the methanol and any catalyst, and by heating and stirring, so that the separation of phase at separation funnel, so that we are separating the glycerol and the biodiesel. And after that biodiesel we received, we are going for the hot water wash, so that any oil particles, any glycerol still is pending, is inside the biodiesel, we can remove. And using that hot water wash we can remove the uh, methanol, we can remove the catalyst also, and then we'll give into the hot air oven, and we'll get the pure biodiesel. So biodiesel refers to vegetable oil or animal fat based diesel fuel consisting of long chain alkyl, that is methyl, ethyl or propyl esters. Biodiesel is typically made by chemically reacting lipids, example vegetable oil, soybean oil, animal fat, with an alcohol producing fatty acid esters. Biodiesel is a drop-in biofuel and thus meant to be used in standard diesel engines, and is thus distinct from the vegetable and waste oils used to fuel converted diesel engines. Biodiesel can be used alone or blended with petrodiesel in any proportions. Biodiesels can also be used as heating oil. Let's see how does biodiesel is production from sunflower oil.
Experiment 113. Biodiesel from sunflower oil. In this video, we will show you how to make biodiesel from sunflower oil. Biodiesel is an alternative fuel for diesel engines made from vegetable oil or animal fat. The structure of biodiesel molecules differs from traditional diesel molecules only by a group known as an ester at one end of the biodiesel molecules. To make biodiesel, we must separate the fatty acetyl from a triglyceride, such as sunflower oil, and then add the ester end. This can be accomplished by a simple step, known as transesterification. We show you how to make your own biodiesel. Potassium hydroxide as a catalyst is mixed with methanol to produce a mixture known as methoxide. This mixture can remove the fatty acetyl from a triglyceride molecule and at the same time add an ester to it. The methanol is consumed, but the catalyst is not. First, pour 30 ml of methanol in a 250 ml Erlenmeyer flask. Then add 1.05 gram of potassium hydroxide. Close the flask with a stopper and stir until the flakes of potassium hydroxide are completely dissolved. Be careful, This reaction is exothermic and will cause the temperature to rise. Measure 150 ml of sunflower oil in a 250 ml beaker. Heat the beaker with sunflower oil to 55 till 60 degrees Celsius. Pour the oil in a 250 ml separation funnel and add the methoxide. Shake the separation funnel vigorously for a total of 10 minutes. Allow the solution to settle. After a while, demixing occurs. The top phase is your biodiesel. When making your own diesel, you can test the created product to see if you have achieved a full conversion. The test detects diglycerides and triglycerides in the produced biodiesel. Important for this test is that both the temperature of the biodiesel and the methanol are between 19 and 21 degrees Celsius. Pour 5 ml of biodiesel in a test vial. Add 45 ml of methanol. Close the vial, shake it lightly and leave it for 5 to 10 minutes. Hold the vial at a 45-degree angle for 10 to 15 seconds. Look for any demixing at the bottom of the vial. Detection of demixing indicates that some of the oil didn't fully transform into the biodiesel. The reaction was successful if there is no noticeable demixing.
Let's see the advantages of biodiesel. These biodiesel are produced from renewable resources and it can be used in existing diesel engines. Less greenhouse gas emissions and it can be grown, produced and distributed locally. So it produces a cleaner biofuel refineries. So it is a biodegradable and it is also non-toxic and it reduced foreign oil dependence. So we can produce in our own country itself. So better fuel economy. So even though it having a advantages, some of the disadvantages of biodiesel are there. So variation in quality of biodiesel and it is not suitable for use in low temperatures because the boiling point of the because the fire point flash point of the biodiesel is very high, and food shortage will come. So increased use of fertilizers in order to grow this much crops, we need to use this much of fertilizers. So the fertilizers will be the level of usage of fertilizers will be increased, and there will be a chances in clogging in engine. And regional suitability, according to the region, the usage of biodiesel will be changes, and water shortage will occur, and use of petroleum diesel to produce biodiesel. Thank you, students. Thank you for watching this session. We'll see you in the next class.